Today in class we worked on problem solving with volume. And before we get into doing one or two examples from the worksheet, I want to remind you that we've been dealing with two formulas for volume in class. One formula is V equals base, which I call big B, times height. And we use this formula for volume, V equals base times height, for any of our prisms. So a rectangular prism, a triangular prism, a trapezoidal prism. We're not going to deal with them as much, but any kind of regular polygon, like a hexagon, so we could have a hexagonal prism. We also use the same formula for the cylinder shape because the cylinder has two bases that are circular. So we get a lot of use out of this one formula. The important thing for you to remember is that the rectangular prism has a rectangle base. So I need to first find the area of the base, which is a rectangle, and then multiply it by the height of the prism. The triangular prism has a triangle base. So I first need to find the area of the base, which will be a triangle, and multiply it by the height of the prism. A trapezoid prism will have a base that is a trapezoid. So I will first need to find the area of the base and then multiply it times the height of the prism. And that's why we did a lot of work with finding the area of rectangles, triangles, and trapezoids at the beginning of this unit. So those of you that paid attention to those formulas and truly have worked on memorizing them like I asked, are going to find these assignments to be much easier than those who have decided it's not worth memorizing the formulas. The second formula that we utilized in class was the formula V equals 1/3 base times height. And you should remember in class that I did that like mini lab in which I demonstrated that it took 3 of the square pyramids being filled with water to fill a cube with the same base as the square pyramid. And that was to demonstrate this relationship of the square pyramid being 1/3 of the volume of the square prism. So now, with our V equals 1/3 B times H, we use that formula for any pyramid and for any cone. Now a cone is going to have a circular base, so we have to get used to using our pi again. And the pyramid has essentially two options for a base. One is going to be triangular, and the second is going to be a rectangular. And so if I have a triangular base, then the first thing I need to do is find the area of the base, which would be the shape of a triangle. And so I would use the formula for a triangle to find the area of the base. Once I know the area of the base, I plug that in for my big B, and multiply by the height of the pyramid, and then finally multiply by 1/3 or divide by 3. If I have a rectangular pyramid, then my base will be the shape of a rectangle. So I will simply find the area of the base, which would be using the formula for area of a rectangle, multiply it by the height, and then multiply by 1/3 or divide by 3. If I have a cone, the base of the cone is going to be a circle. And so I will find the area of the circle, which is my base, multiply by the height of the cone, and then multiply by 1/3 or divide by 3. So it's very important that you can distinguish between these various shapes. You'll want to refer back to your notes. You will want to refer back to the PowerPoint slide that I loaded to the Weebly site both Thursday and Friday, because those provided reviews of not only these two formulas, but also a lot of these regular shapes. Well, now let's look at an example problem. A glass paperweight is in the shape of a triangular pyramid. That's not a triangular pyramid. That is a rectangular square pyramid. As shown, what is the volume of this weight to the nearest tenth? So since I'm dealing with volume, I know I'm going to be using the formula V equals, and I have a pyramid, which tells me I will be using the formula 1/3 base times height. And the very first thing I'm going to want to do, I'm going to do it right down here, is find the area of my base. So my base is equal to the area of a square, so 1.5 times 1.5 and that's going to equal, or my B value would be 2.25. Well, now that I know what B is, and I can look at my image to find the height of the pyramid, I can fill in all my variables and be able to solve. So V equals 1/3 times my base of 2.25 times my height, which is clearly identified there as 2. And so now I'm going to simplify these expressions by multiplying straight across. 2.25 times 2 would be 4.5. 3 times 1 times 1, well, that would be 3. Again, simplify one more time. 4.5 divided by 3 is 1.5 inches cubed is the volume of this weight to the nearest tenth. I'm going to do the cone from problem 3. Again, the cone from volume problem 3, we'll use the formula V equals 1/3 base times height. And so the very first thing I'm going to do is identify the base. And the formula for finding the area of a circle is pi r squared. Now we're given a diameter here of 24, and the diameter is twice the distance of the radius, so half of this would be 12, which means I have pi times 12 squared. 12 squared is 144, so my base is equal to 144 pi. Now that I know the value of B, and we can clearly see the height of the cone is 16 feet, I can plug in these values. V equals 1/3 times a base of 144 times a height of the cone is 16. I will multiply straight across, so 1 times 144 times 16 is equal to 2304. 3 times 1 times 1 is 3. So my volume for this cone is 768 feet cubed. Now the problem asks, which of the containers should your group choose during this relay? So I would want to find the volume of each of my 4 shapes and then compare their capacity and make a justification for which one I would use for this particular relay.